As stated before, humans can hear sound waves that fall between about 20 hertz to 20,000 hertz. The ear is a very sophisticated structure that allows us to transform energy from one form to another. And we perceive the world with our senses, hearing being one of them. It's maybe difficult to see, but in this picture we can see an ear, which I'll outline with yellow. An ear has a structure that allows sound to be collimated or piped into the ear canal. So just imagine sound waves come from some outside source. They're going to enter the ear canal. When these sound waves interact with the eardrum or the tympanic membrane, they do work on them, and it causes them to vibrate to and fro, like a simple harmonic oscillator. In turn, there are three small bone structures, the smallest bones in the human body: the hammer, anvil, and stirrup. This vibrational energy will transfer from the tympanic membrane through these teeny tiny bones, and eventually the vibrations will enter the cochlea, where they get transformed into electrical currents, which allows us to perceive sound. The ear is also connected to your throat through what's called the eustachian tube. So sometimes when you get sick, this eustachian tube will get blocked. You get stuffy, you maybe have a hard time hearing. The inner ear also contains a different structure, or series of structures, called the semicircular circles. And these allow us to give us a spatial orientation or balance. And they're oriented in, let's say, the X direction, the Y direction, and the Z direction, which gives us a sense of up and down. But again, the main purpose of this illustration is to look at how we respond to sound. Sound gets transformed from one form of energy, waves, to electricity. It's one of the ways we perceive the world around us. The outer ear, sound waves travel down the ear canal to the eardrum, which vibrates in response. Within the middle ear, the hammer, anvil, and stirrup transfer the vibrations to the inner ear. And within the inner ear, the cochlea transforms vibrational energy into electrical energy, which sends signals to the brain. The ear sensitivity varies with frequency. Humans do not hear all pitches or frequencies the same way. Usually the middle frequencies we hear better than low or high frequencies. So this is a table that translates sound levels at different frequencies. And sound waves can be produced by various musical instruments. And if these sound waves fall between 20 and 20,000 hertz, as we said before, sound will occur, and we can perceive that. Musical instruments produce sound in various ways: vibrating strings, vibrating membranes, or vibrating air. The shape of these strings, membranes, or air columns determine which musical note will be played, or what sound we hear, or what frequency or pitch we hear. The vibration may be started by plucking, striking, bowing, or blowing. So when we do work on these objects, the strings, membranes, or air columns, vibrations are transmitted to the air and then to our ears.